What if one machine could help train an intelligence more powerful than anything humans have ever built? Deep inside NVIDIA's new AI supercluster, thousands of fast connections, massive chips, and extreme computing power are coming together to push AI into a completely new age. The rack that stops looking like a rack. At first glance, NVIDIA's new AI machine does not feel like a normal server rack at all. It feels like a wall of concentrated intelligence, packed so tightly with computing power that the whole structure starts to look less like IT hardware and more like the engine room of a future digital mind. This system is called the GB200 NVL72. According to NVIDIA, it connects 36 Grace CPUs and 72 Blackwell GPUs inside a rack-scale, liquid-cooled design. That matters because this is not just a room full of separate chips doing their own jobs. NVIDIA says the system uses a 72 GPU NVLink domain, so the GPUs can behave like one massive GPU, built for the kind of giant AI workloads that smaller systems struggle to handle. And that is where the story becomes interesting. When a machine is built this way, scale stops being a simple numbers game. It is no longer just about having more GPUs. It is about making them move together fast enough to train and run trillion-parameter large language models without breaking the flow of computation. NVIDIA says this design can deliver much faster real-time inference for those giant models, which shows exactly what this system was built for. So the real question is no longer, how big is this machine? The real question is, what happens when dozens of powerful GPUs start acting like one? Why one giant AI machine beats a crowd of smaller ones? A giant AI model does not slow down only because the math is hard. It slows down because the chips have to keep talking to each other, passing huge amounts of data back and forth without creating traffic jams. That is where most ordinary GPU clusters start to lose their rhythm. This is why NVIDIA puts so much focus on NVLink and NVSwitch. On the GB200 NVL72, NVIDIA says the 72 Blackwell GPUs are connected inside the largest NVLink domain it has offered for this system, so they can act more like one tightly linked engine instead of dozens of isolated processors. NVIDIA also says the NVLink switch system provides 130 terabytes per second of low-latency GPU communication inside the rack. That changes everything for giant AI workloads. When model sizes climb into the trillion-parameter range, the system is not just crunching numbers. It is constantly moving activations, weights, and intermediate results between chips. A faster interconnect means less waiting, less wasted compute, and a much better chance of keeping the whole training or inference process smooth. NVIDIA describes NVLink as a high-speed interconnect built to move data quickly between GPU and CPU processors in accelerated systems. So the power of this machine is not only in the GPUs themselves. The real power is in the conversation between them. Fast, dense, and synchronized. And once that conversation becomes efficient enough, the next challenge is no longer connection. It becomes orchestration. The super training blueprint behind the machine. A rack full of powerful chips is impressive, but a true AI supercluster is not built from chips alone. It only becomes useful when compute, networking, storage, software, and management all move in sync, like parts of one living system. That is the bigger idea behind NVIDIA DGX SuperPOD. NVIDIA describes it as a full-stack data center platform, not just a pile of hardware. In NVIDIA's own wording, it combines computing, storage, networking, software, and infrastructure management that are optimized to work together at scale. That matters because training giant AI models is not only about raw speed. It is also about keeping data flowing, keeping workloads balanced, and preventing the whole system from slowing down under its own complexity. NVIDIA also says DGX SuperPOD is built for the hardest AI training and inference jobs, and that it can scale to tens of thousands of NVIDIA GPUs for state-of-the-art, trillion-parameter generative AI models. That gives us the real picture. The GB200 NVL72 may be the dramatic rack we can point at, but systems like DGX SuperPOD show the larger blueprint around it, the environment where giant AI models are actually trained, tuned, managed, and kept running. And this is where the story gets bigger than one machine. NVIDIA is not only building faster processors, it is shaping a full training ecosystem where hardware, software, and infrastructure are designed to behave like one coordinated factory. Once that happens, the machine is no longer the final product. It becomes the foundation from model training to AI factories. Something important is changing in the world of AI hardware. These systems are no longer being described as machines that only train models and then sit quietly in the background. NVIDIA is increasingly framing them as AI factories, places where intelligence is produced at scale, again and again, through training, fine-tuning, and high-volume inference. That idea matters because the job of a giant cluster does not end when a model is finished training. NVIDIA's own AI factory description says these systems are built to manage the entire AI lifecycle, from data ingestion to training, fine-tuning, and high-volume AI inference. In other words, the output is not just a trained model. The output is continuous intelligence, tokens, decisions, responses, predictions, and services flowing out of the system every day. Now place the GB200 NVL72 inside that bigger picture. NVIDIA says this rack-scale system connects 36 Grace CPUs and 72 Blackwell GPUs in a liquid-cooled design, with a 72 GPU NVLink domain that acts like a single massive GPU. That makes it easier to understand why NVIDIA talks this way. The company is not only building faster chips, it is building dense, pre-engineered systems meant to become the core units of much larger AI production environments. And that is the real shift. A supercluster like this is not just a research toy for a few labs. It points to a future where AI infrastructure starts to look like industrial infrastructure, expensive, permanent, and central to how companies create value. Once that happens, the question is no longer just what the machine can do. The question becomes, who will have access to power on this scale? And what will they build with it? The human stakes. Who actually uses power like this? It is easy to look at a machine like this and think only about silicon, cables, and cooling pipes. But the real story begins with people. The researchers trying to train larger models, the engineers trying to serve them faster, and the companies racing to build AI systems that users can actually depend on. NVIDIA positions the GB200 NVL72 for exactly those frontier workloads. The company says the rack-scale system is built for trillion-parameter large language models, and that it delivers 30 times faster real-time inference for those models, along with 10 times greater performance for mixture of experts architectures. That tells us who this machine is really for. Teams working on the heaviest forms of AI, where ordinary infrastructure starts to choke under the size of the job. But the users are not only elite research labs. NVIDIA's own AI factory and enterprise materials show a much broader picture. Enterprises deploying inference at scale, developers building production AI systems, cloud platforms offering GPU access, and organizations that need the full cycle from training to fine-tuning to high-volume deployment. NVIDIA describes an AI factory as infrastructure that manages the entire AI lifecycle, while DGX SuperPOD is presented as scalable infrastructure for the most demanding AI training and inference workloads. That is why a supercluster like this matters in human terms. It shortens the gap between an idea and a usable model. It gives builders a better chance to train bigger systems, serve more users, and push into reasoning-heavy AI that would otherwise be too slow, too costly, or too fragmented to run well. And once that kind of power becomes available, even through cloud access, people stop asking whether they can build the next generation of AI. They start asking how far they can push it. Could this be the infrastructure for the most powerful intelligence yet? Now the story reaches its biggest question. When a machine is built to connect 72 Blackwell GPUs and 36 Grace CPUs inside one liquid-cooled rack, and when NVIDIA says that rack can act like one massive GPU, we are no longer looking at a normal upgrade cycle. We are looking at infrastructure designed for a different scale of ambition. NVIDIA is careful about how it frames that ambition. The company says the GB200 NVL72 is built to unlock real-time trillion-parameter large language models, and its broader AI factory language describes infrastructure that manages the full AI lifecycle, from data ingestion to training, fine-tuning, and high-volume inference. That does not prove the arrival of superintelligence, but it does show the kind of foundation NVIDIA believes will be needed for the next generation of frontier AI systems. And that is what makes this machine feel so important. The shift is not just from smaller models to larger ones. It is from isolated AI experiments to industrial-scale intelligence production, systems engineered to produce more reasoning, more responses, more automation, and more capability over time. NVIDIA's own Blackwell and AI factory materials frame this as a new era of computing, built around scale, speed, and tightly integrated infrastructure. So, could this help train the most powerful intelligence the world has seen? Maybe. But the honest answer is more precise than that. This is not the intelligence itself. It is the power plant behind it. The kind of machine that makes people believe the next leap is no longer blocked by imagination alone, but by who can build, afford, and control systems at this scale. This is no longer just a story about faster chips or bigger servers. It is a story about the machines that may shape the future of intelligence itself. And if this is only the beginning, imagine what comes next. If you enjoyed this video, like, share, and subscribe for more.